Of section 4.5 matrix inverses. Yesterday we did a lot by hand, but today we're going to take it and do most of our work by calculator. So make sure you've got your calculator out and ready, and we'll be set to go. As we were looking yesterday, we looked at a manual way of trying to find the inverse of A, and once again, we'll look at that just briefly today, but then we're going to work on the calculator methods. So here we have a problem that says to find A inverse, and we can set it up just like we did yesterday, where we've got 2, -4, 1, 0, 1, -2, 0, 1, and if we took -2 times row 1, row 2, -2 times row 2, and add it to row 1, that's going to eliminate so that we can get a 0 here. I know usually we put a 1 here first, but I just want to show you something that happens. So when we do -2 times row 2 and add it to row 1, we do get a 0 here, but the problem is -2 times -2 is 4, and that'll give a 0 here as well. And once we have a situation where you've got a 0 and a 0, we have a problem, and the problem is that it's going to be impossible to get a 1 here by any kind of row operations and still maintain a 0 here. So what that tells you is that 0x plus 0y equals 1x and -2y. It just doesn't work out. We have no inverse in this case because you can't get it in that form where you would show the inverse. So in this case, you would say there's nothing that you can multiply times this that's going to give you that identity matrix 1, 0, 0, 1. So this kills it as far as getting an inverse. Make sense? Okay, making sense. So I told you we're going to use calculators. We're going to use that as far as what we use the inverses for. A way that we use the inverses is that we need to, just like in a regular problem where you can do inverse operations to both sides of an equation in order to solve it, if we were to write this equation out like this, 2, -3, 1, 5, there's a matrix with the coefficients of the variables in this system. Then x and y go into the second matrix. If we think about our matrix multiplication, this makes sense because it would be 2x minus 3y if you take this whole thing as a unit and swirl it up here. And then that would be 1x plus 5y equals then the 2 in this spot. Now, just like if you have something simpler, like if you had 3x equals 18 and you wanted to solve this, you would do an inverse of the 3. You would do an inverse operation. The inverse operation of multiplication is division, so you would divide by 3. The inverse operation, though, for a matrix multiplication would be to multiply times A inverse. So if we multiply both sides by A inverse, we would find the answer to this system. What that looks like is right here. A inverse times the original matrix is going to give you that 1, 1, 0, 0 scenario. But A inverse times this is going to actually give us the answer. And we have calculator steps to do this. We want to multiply A inverse times this matrix, and it gives you, it is a method of doing that. So we're going to take our calculator. You do have to set up this thing manually so you know what you're putting in the calculator. But the first thing we need to do is enter matrix A and matrix B into the calculator. Here's matrix A, here's matrix B. So we need to go into your matrix section, second matrix, go into edit, so we can edit matrix A. And this is a what by what matrix? It's a 2 by 2, so we want to do 2 by 2, 2 by 2. And then we need to fill in our numbers, 2, -3, 1, 5. Once again, when you do the -3, make sure you're using the gray negative instead of the blue negative. 1, 5. So there's our matrix A. And then we can go back out. We can go to matrix again. And then we can edit our second matrix. So we go down to matrix B. Matrix B here is how many by how many? 2 by 1. So we put in 2 by 1. And we enter our two numbers into that. So we're entering in 4 and 2. Right, now, the math that we actually have to do with this is A inverse times 4 matrix B. So A inverse times matrix B. So we need to get our matrix, second matrix, and we just want to choose matrix A. In order to get our inverse, use the inverse button that's right at the same button that you found for matrix. So we've got A inverse times, and then pull up matrix B, down to B. So A inverse times B, and I accidentally hit it twice, but it should be 2, 0. So our answer, A inverse B, is 2, 0. So 2, 0 equals x, y, because remember these cancel out. A inverse times this gives me the identity matrix, and when I multiply that times xy, it cancels out. So xy equals 2, 0, so our ordered pair is 2, 0 for the answer. So just a nice little calculator method. I'm able to show you now how inverse matrices work. Back in the old days, you used to have to do that all by hand. So you'd have to find that inverse matrix and then go ahead and multiply it, which takes far longer than it would just to solve the system. So it wasn't necessarily done much. But now that we have the calculators, we can actually take a look at what's happening, understand about the inverse matrices, and then just do the work by calculator. If you have to set it up by matrix, you can then use your inverses to find the actual answer. Questions?